Hello, folks. Our next conic section to discuss is the hyperbola. You're going to notice a lot of similarities between hyperbolas and what we've just talked about for ellipses. So let's get into it. By definition, a hyperbola is considered to be the set of all points in the plane in which the difference of the distances from two distinct points, called the foci, is constant. So that distance, if you were to subtract the two distances from one another, that would stay constant throughout the whole curve. So it's almost kind of like if you invert an ellipse inside out. This is what you get. So if you look at this diagram here, it's got all kinds of stuff on it. The actual hyperbola, though, is this highlighted curve. So again, it's almost kind of like taking an ellipse, flipping it inside out. And then, of course, we're going to talk about all this stuff that's here in the in-between. Okay, your center of your hyperbola is the midpoint of the line segment whose endpoints are the foci. Okay, or you can also say that whose endpoints are the vertices. If you'll notice, the center point is right here, directly in between those two curves. So it's not actually, the weird part is that the center is not actually on your curve. The point on each branch of the hyperbola, so the yellow things that I've just highlighted, that is nearest the center is called a vertex. Okay, so there are basically 5 points that you're going to graph every time you graph the hyperbola. You're going to graph the center point. You're going to graph the two vertices, which are on the curves, and then you're going to graph the two foci. So those 5 points you're going to graph every time. In addition to graphing points, what's going to help you figure out where your curve should be is you're also going to graph the asymptotes. So there are two asymptotes. Those are the lines that the curve approaches as it recedes from the center point. Okay, and again, that kind of lets you know the shape that your curve should take as it travels away from the center point. Okay, to explain other parts of this hot mess of a diagram here, the hyperbola has two axes of symmetry. The line segments connecting the vertices, so in this case, it's going to be horizontal. That's not always the case. But anytime, whichever one connects the vertices is called the transverse axis. I'm going to say that's like the main axis. And it has a length of 2A units. 2A units. So you'll notice on the picture here, A is the distance between C and a vertex. Okay, the segments perpendicular to the transverse axis through the center is called the conjugate axis, and it has a length of 2B units. And in this case, it is vertical. So that conjugate axis there. Now, the axis is the whole length. I need to specify that. So what I've highlighted is just B. 2B, or not to be, would be that length doubled. And notice it would fill in this rectangle that's in the middle of these two curves. So in an ellipse, we have a major and a minor axis. Major is always the bigger one. Minor is always the smaller one. For a hyperbola, we have a transverse and a conjugate axis. Neither is always bigger than the other. So that's one of the main differences. This is an instance where a hyperbola differs from an ellipse. In an ellipse, A is always bigger than B no matter what. In a hyperbola, A is always the distance from the center to the vertex, no matter the orientation of the hyperbola. It is not always bigger. So that's why we don't use special words for the axes like major and minor, because it really doesn't matter which one's bigger. The transverse will always connect the vertices. I will say that one's like the main axis. Sometimes it's bigger, sometimes it's smaller than the other one, which is the conjugate one. Okay, and in relation to the variables, we have lots of them here, right? A, B, C. Their relationship in an ellipse, c squared is equal to a squared minus b squared, but in a hyperbola, c squared is equal to a squared plus b squared. So we have two different orientations that we could have for a hyperbola. One that was in this diagram up here where our two curves go to the left and to the right, just like we have here, or it can be flipped upside down to where you have your curve is flipping upward and downward. So it almost kind of looks like two parabolas that are flipped out from each other. So the standard equation, again, is very similar to that of an ellipse. Of the one that has the horizontal orientation, it starts off just like an ellipse. X minus h squared over a squared, y minus k squared over b squared equals 1. The only difference between a hyperbola and an ellipse in terms of the equation is that there's a minus sign in between the fractions instead of a plus sign. Okay, that is the only difference. It basically is just saying that either your x squared term or your y squared term is negative. And that's actually how you get the other one. To get your hyperbola flipped up and down, the y term is just first. So y minus k squared. A squared is still first, just like it is in an ellipse. You always write the a term in the first denominator. Minus x minus h squared all over b squared is equal to 1. So you can have either one of these equations. And then there are different aspects to the hyperbola that we're going to graph in addition. Now, just to be clear, HK is still considered the center point. A is the distance from the center to the vertex. So in this case, for the first one, A would be this distance. But in the vertical one, A would be this distance. Okay, again, it's not always necessarily bigger. B is going to be a little bit challenging for me to draw on these pictures right now, so I'm going to hold off and talk about what B looks like visually once we do an example. It is half the distance of the conjugate axis, though, which we talked about earlier. Okay, the asymptotes. What those do, and we're going to kind of sketch them, it's not going to be perfectly, but the asymptotes essentially kind of help you guide your curves. They go through the center point. So notice as I sketch them, you want them to go through your center point. And in order to get them, they will end up having opposite slopes. Okay, not opposite reciprocal slopes, because those would always be perpendicular, just the opposite slopes. So we have equations that we can use to find those asymptotes. For this horizontal orientation hyperbola, the asymptote is found by doing y minus k is equal to plus or minus b over a times x minus h. And this, if you can't tell, is like point slope form of a line, where it's y minus y1 is equal to m times x minus x1. So b over plus or minus b over a, that is the slope. So when we graph our lines, that's what we're going to follow to know how we should graph that line. Okay, asymptotes for the vertical parabola, I keep calling it parabola, the vertical hyperbola is similar. It's also y minus k equals plus or minus, but instead it is a over b times x minus h. Again, plus or minus a over b, this is the slope for those. One has a positive slope, one has a negative slope. Vertices for a horizontal hyperbola. Again, your vertice and your foci, they will always start at the center point and then they will extend further. So since this one is horizontal, we're going to be adding on to the x-axis or to the x-coordinates. So you start at your center HK, but to H we're going to be adding and subtracting A, and then leave K alone. And then for the foci, we're going to go even further in. So notice that the foci are always on the inside of the curve. So these two are the foci inside the curves. To get the foci coordinates, you do h plus or minus c, comma k. Okay. Vertices and foci for the vertical hyperbola are similar, except you leave h alone, but since we're stretching in the y direction to the k value of the center point, for the vertex, you're going to get plus or minus a, and then for the foci, it'll be plus or minus c. The equation of the transverse axis for the horizontal hyperbola is y equals k. The conjugate axis is x is equal to h. And that makes sense because those axes will go through the center point. And then for the vertical orientation, they're just opposite. The transverse axis, which connects the vertices, is x minus h. Conjugate axis will be y is equal to, I said x equals h, sorry, and then y equals k. So we're going to use all of these features to do the next 6 examples. Okay, the first couple of examples are very straightforward. I give you a picture and I want you to write the equation for the parabola using what I give you here. Okay, so in order to write the equation of a parabola, let me rewrite it up here so that we know what we're looking for. It's just like an ellipse, x minus h squared over a squared minus, that's the difference in an ellipse, y minus k squared over b squared is equal to 1. And again, these two numerators are interchangeable depending on if your vertices are along the x-axis or they're along the y-axis. Okay, for number 1, first thing to notice is that our vertices are horizontal with one another, which tells us that we know that x squared term will have to be first. Okay, our center point is the intersection of the asymptotes. Okay, so the bolded curves are part of the hyperbolas, but the center point is going to be the point directly between them. So this coordinate here is, let's see, HK, our center point, will be 1, negative 2. And then to finish writing the equation, we need A and we need B. So A is the important one. A is always going to be half the distance from, well, it's going to be half of the transverse axis, but it's mainly, I guess, easily more recognizable as distance from center to vertex every single time. A is center to vertex. So from the center point to the vertex point is 2. So I know that A is equal to 2. B, this is new. In order to get B, by definition, we said B is half the distance of the conjugate axis. So what you'll notice in the examples that I drew up here, or that was typed up here rather, is there's always can be this rectangle that can be drawn between the two curves. And that kind of tells you the length of the axes. So in order to draw that rectangle, you're going to basically, you don't want to draw just any rectangle, so don't copy what I'm about to draw. I just want to show you this. Let me make it even smaller. Okay, what's wrong with this gray rectangle is that its vertices don't touch the asymptotes. So when you draw the rectangle, in order to figure out what your conjugate axis is, you need to draw it in such a way that your rectangle, let me get a brighter color, that your rectangle has 4 intersections with the asymptotes. So now this red rectangle that I've drawn here intersects the asymptotes at all 4 of its vertices. So maybe that's worth writing down here. When you draw the rectangle must intersect the asymptotes. Now, I want to reiterate, the rectangle does not have anything to do with the actual graph of the hyperbola. What that rectangle allows us to do, though, is get the length of the conjugate axis. So we know that the transverse axis, the main one, which is between the two vertices, we already got that distance was 4, and then half of it was 2. That's where A came from. b, however, comes from half the distance of the other axis, in this case, the conjugate axis. So that distance will be 1, 2, 3, 4. So b is equal to 4. And then once you have h, k, a, and b, then you just plug those into your equation. So x minus h will be x minus 1 squared over a squared will be 2 squared, which is 4. Minus y minus negative 2 will change to y plus 2 squared. Over b squared will be 4 squared, which is 16. And then just like an ellipse, every parabola will always equal 1. Okay, number 2. Same direction, so I want you to write the equation. So first thing that I like to pay attention to is which variable will come first. Well, since this hyperbola is flipping up and downward, in other words, its vertices are vertically related, then I know that my y squared term is going to be first. So I'm just going to put that there to keep that in mind. The main thing that we need in order to write the equation of our hyperbola is the center point. Remember, the center point is the intersection of your asymptotes, or half the distance between, or the midpoint between your vertices. Either way, in this case, we have a really lovely center point at 0, 0. Okay, and then A and B come from half the distances of the axes. Or you can think about A as the distance from the center to one of the vertices. So if I start at the center, counting down to one of the vertices, I get 3. And then B, again, is half the distance of the conjugate axis. So again, we've got to draw that rectangle. So you want to start drawing off a line that will intersect your vertex. And you want to draw it in such a way that it actually extends and intersects with the asymptotes. So extend it until all the way until you hit the asymptotes, and then such that when you drop it down to hit the other part of the rectangle, that obviously it all matches up. So if I have this drawing, or this rectangle, then half of the length of that axis is 5. So b is equal to 5. So then when I substitute that into my equation for an ellipse, I get x minus 8. Oh, I'm sorry. We know y is coming first because of the way it's opening. So we're going to have y minus k is 0 squared over a squared still comes first every single time no matter what, even though it is smaller. Okay, in this case it is smaller. So that'll be over 3 squared minus x minus 0 squared all over b squared will be 5 squared is equal to 1. And then always clean it up. Simplify everything as much as possible. So y minus 0 is just the same thing as y squared. Over 3 squared is 9. Minus x squared over 25 is equal to 1. Okay, the next 4, I give you a blank graph and I need you to graph the parabola and tell me all of the information that I have spelled out here. I want to know that those pieces of information about your parabola. Oh, look at that. I put parabola. See? Oh, I put it for the first section too. All right, maybe I'll change these on y'all's notes because I haven't made copies yet. So on your notes, hopefully they already say hyperbola. Hyperbola. Okay, number 3, if I'm going to graph this hyperbola, the first thing I want to get is the center point. That comes from the x's and the y's and what numbers are attached to them. There is no change with the x, it's just x squared. So I know that my h is 0, and then y minus 5 indicates that my k is a positive 5. So there's my h and k. So let me graph that first, the point 0, 5. Just up on the y-axis 5. In order to get a and b, we know that a squared is always the first denominator. So if a squared is 9, then that indicates that a must be 3. And if b squared is the second denominator is 81, then that indicates that b must be 9. Okay, so that's A and B. If you want, you can go ahead and graph this, like using A and B, make the square that we did in the last two problems, and then go from there. I'm just going to wait. I personally like to graph my asymptotes first. So if we look at the front page of your notes, the asymptotes, again, I want you to pay attention to the fact that x squared is first. So anytime x squared is first, that means our vertices are going to be aligned along the x-axis. So our curves are going to look like this. The asymptotes for those types of hyperbolas are denoted by the equation y minus k is equal to plus or minus b over a times x minus h. Well, y'all, we have literally all of these variables. We just need to assemble them into this formula. So if I do that, I get y minus k is 5 is equal to plus or minus b is 9 over a is 3 times x minus h is 0. And then we just want to simplify this a bit. There's nothing we can do with y minus 5 equals plus or minus 9 divided by 3 is 3, and then x minus 0 is just x. So this would be the equation of our asymptotes. Now, if you wanted, you could put 5 on the other side and write it in slope-intercept form, but I'm okay if you leave it like this as long as it has been simplified. And here's how it works. In order to graph your asymptotes, you really only need to pay attention to the slope. Okay, the slope is plus and minus 3, and you graph that slope from this center point. So you don't start at the origin, start at the center point that we've already graphed, and then we're going to have two lines. From that center point, one line's going to have a slope of positive 3, so you go up 3 and over 1, down 3 and to the left 1, and you could do a few more if you want, but it's just to give you an idea of where that line should go. And then the other line will have a slope of negative 3, so up 3 to the left 1. So those are the asymptotes. So I know my curves are going to have to fit inside of these asymptotes. Okay, to get the vertices, again, you can use the A's and the B's. We know that A is the distance from the center to the vertex. So if you have your center point here, we already know our curves are going to look like this. Then you could just count 3 to the right and then 3 to the left, and then bam, you have your vertices. Or if you prefer using, I'll say the formula that we wrote on the front side of these notes, it's given by, the vertices are given by h plus or minus a comma k. So however you want to think about it, if you want to just visually say, oh, I know a is 3, so I'm going to go a distance of 3 in each direction, then you're good. If you want to do it algebraically, then just fill in your variables here. H we know is 0, plus or minus we know a is 3, and then k is 5, which is telling us our two vertices are at 3, 5 and negative 3, 5, which are the 2 points that I've already graphed there. Okay, once you get that, once you have the center point and your two vertices, you can estimate your curve. And your curve just kind of needs to follow the asymptotes. Oh, that one didn't look very pretty. That's better. And then lastly, to get the foci. For the foci, you definitely have to just use the equation to figure out what those are. If you use your table, the foci is found by doing h plus or minus c, comma k. We haven't found c yet. So in order to find c, we wrote earlier that c squared is equal to a squared plus b squared, which is equal to, let's see, a squared. It'll be 3 squared plus 9 squared. So that'll be 9 plus 81, which will be 100. I feel like I did this wrong. Oh yeah, I totally did it wrong on my notes that I wrote earlier. So I hope this is well. All right. Anyway, 3 squared plus 9 squared will be 9 plus 81, which is going to be 90. So then that means C is going to equal plus or minus the square root of 90. which we can break up to be, let's see, 9's a perfect square. So it'll be plus or minus square root of 9 times square root of 10, which will be plus or minus 3 square roots of 10. So for our foci, that's going to be h is 0 plus or minus 3 square roots of 10, comma 5. So if I clean that up a little bit, it'll just be plus or minus 3 square roots of 10, 5. Ooh, lots of numbers there. Okay, and then you can estimate where that is. 3 square roots of 10 is about 9.4, which is almost going to be off the graph. So one will be over here at the positive 9.4. Let me draw. There we go. So I'll label that F for one of the foci. The other one will be at about negative 9.5, 9.4. So I'll label that one F for another foci. Okay, number 4 is a different question. I don't give you the equation. I just give you some information about the hyperbola that you have to figure everything out. So the center is at 4, negative 2. So let me graph that first. So I know there's my H and K. A is 2, B is 3, and it has a vertical transverse axis. That tells us that we know that our vertices are going to be up and down from the center point because it has a vertical transverse axis. And if we know that A is the distance from the vertex to the center point, then from this center point I can count 2 up and 2 down to get my vertex points. So you don't even have to use the formula. You can just use what you know about the definition of A in order to graph those. So in standard form, I have my 4 variables, H, K, A, and B. The other thing to note is since it is a vertical transverse axis, we know that y squared has to be first. So I'm going to get y minus negative 2 will be y plus 2 squared. Over a squared is always the first denominator, so 2 squared is 4. Minus x minus 4 squared over b squared, 3 squared is 9, which is equal to 1. Okay, asymptotes this time are going to be the other direction. This one's going to be flipped the other way. So if you look at the second graph on the front of your notes, the formula for asymptotes for a vertical transverse will be y minus k equals plus or minus a over b times x minus h. So you put a over b instead, which will be, let's see, y minus k is negative 2, so that'll be y plus 2, is equal to plus or minus a over b will be 2/3 times x minus 4. So again, when you graph these asymptotes, you don't have to worry about like writing both that equation into 2 separate slope-intercept forms. Literally, once you write the equation from your center point, you will count a positive slope of 2/3 and a negative slope of 2/3. So from my center point, I'll go up 2 over 3, down 2 over 3, and that's the one that has a positive 2/3 slope. And then this one will have a negative 2/3 slope. Okay, I already found my vertices by hand, or you can use the formula if you wish. Either way, you should get 4, 0 and 4, negative 4. And that's enough to graph your curve. The only things necessary for the curve are the center, your vertices, and your asymptotes. The foci are going to be the last aspect. For foci, it's going to be h comma k plus or minus c. Well, in order to get c, we're going to do c squared equals a squared plus b squared, which is going to be 4 plus 9. which is going to be plus or minus, so C is going to be plus or minus the square root of 13. So your foci is going to be 4, comma, negative 2 plus or minus the square root of 13. So then to graph these two foci, one of them will be 4, comma, negative 2 plus square root of 13. The other one will be negative 2 minus square root of 13. And if you estimate what that is, the square root of 13 is about 3.6. So that means from the center point, you'll count 3.6-ish in both directions. And remember, your foci should be on the inside of your curves. Okay, number 5 is the doozy. We've done one like this for circles and a couple like this for ellipses, where I don't give you the equation in standard form and you have to make it happen. So in order to do that, I've got to rearrange my stuff. So I'm going to group my x's, negative 4x squared minus 24x. I'm going to leave room for a new c. Plus 9y squared minus 90y plus a new c is equal to my constant on the other side will be negative 153. So the difference here, again, because we have a hyperbola, is that one of our leading coefficients is kind of going to be negative. So what that means is, notice that the x squared term is. So I want to factor out that negative 4. And we'll end up rewriting it in a different order later. When I factor out that negative 4, I get x squared plus 6x, because I factored out the negative, plus whatever the new c is, plus we need to factor out the 9 to get a leading coefficient of 1. So that'll be minus 10y plus whatever the new c is, minus 153. To get the new c, we do b over 2 squared. So that'll be 6 over 2 squared. 6 over 2 is 3 squared, which is 9. So that's the new c for the x's. The new c for the y's will be negative 10 over 2 squared. I don't even know what that number looks like. Negative 10 over 2 squared, which is negative 5 squared, which is 25. So remember that the tricky part is when you add these new c's. So like when I add 9, technically I'm adding 9 times the negative 4 on the outside that's being distributed into that 9. And same thing over here to the y's. When I add 25, technically I'm adding 25 times the 9 that's being distributed in. So then when I clean all this up, I get negative 4. Again, I can rewrite this trinomial as x plus 3 squared plus 9 times y minus 5 is what this trinomial can be squared, is equal to 36. Now, you're almost there. Hyperbolas also have to equal 1. So in order for that to happen, I need to divide the right side by 36. Whenever I do to the right side, I've got to do to everything on the left side. Okay. In addition, since my x is negative, I'm going to switch both of those terms. Okay, well, let me do one step at a time. So when I do that, I get x plus 3 squared over, well, that'll be negative, and then 4 over 36 reduces to 1/9, so that'll be over 9, plus y minus 5 squared. 9 over 36 reduces to 1/4, so I'll put a 4 in the denominator, equals 1. So then again, I'm going to do one more switcheroo because this x is negative. That means the actual standard equation will be y minus 5 over 4, y minus 5 squared over 4, minus x plus 3 squared over 9 is equal to 1. So all of that just to get the standard equation. Once you have that, the center point, hk, h comes from the x. Since it's x plus 3, it'll be negative 3. Positive 5. A is always the square root of our first denominator. So if a squared is 4, then a is 2. If b squared is 9, then b is 3. To get the asymptotes, we're going to do y minus k equals plus or minus a over b times x minus h, which means it'll be y minus k is 5 equals plus or minus a over b will be 2/3 times x plus 3. So let's go ahead and start graphing this. The center point's at negative 3, 5. So 3 to the left and then 5 up. And again, you can use A and B to graph the rectangle if you want right now. I know that my y squared term is first, which tells me that I know that my vertices are going to be up and down from the center point. So since A is 2, then I know there's a distance of 2 up from the center and 2 down from the center for the vertices. And then for the asymptotes, we just found that the slope was another 2/3. So that means from the center, I'm going to count up 2 and to the right 3 and down 2 to the left 3 for a positive 2/3 slope from an asymptote. 2, 3, and then do the negative 2/3 to get that asymptote. Again, I did my vertices by hand, although you could do h comma k plus or minus a. And you will end up with negative 3, 7 and negative 3, 3. And again, those pieces of information are enough to graph the curves. And then we'll do the foci last. So the foci, similar to the vertices, it starts off with h, but then it's k plus or minus c. So then that's going to be, we need c squared first of all. So c squared is a squared plus b squared, which will be 4 plus 9, which will be 13. So that means c is plus or minus the square root of 13. So it means our foci are going to be at h is negative 3, comma 5 plus or minus the square root of 13. And then to estimate where that is, again, the square root of 13 is about 3.6 or so. So from the center point, you can go 3.6, let's see, 1, 2, 3, upwards. And then from the center, 3.6 downwards to get those foci. Again, the foci are going to be inside the curve. All right, I know this video is long. Thanks for hanging with me. Last question. The length of the conjugate axis is 8 units long, and the vertices are negative 3, 9 and negative 3, 5. Write the equation, find all this other stuff. So this one, we definitely want to go to the graph first. The length of the conjugate axis is 8 units. Can't do anything with that. Let's go ahead and graph these points first. The vertices are negative 3, 9. So it's going to be at the very tip top of the graph. Negative 3, 9, and negative 3, 5. So these are the vertices. What this tells us is if these are the vertices, then the center point is between the two vertices, directly between them. So that means the center point, if these are 4 away, has to be here. So that means the center point coordinate will be negative 3, 7. So there's h and k. A is the distance between the center point to a vertex. So we know A has to be 2 because it's half of that axis. And then we know that B is half of the conjugate axis. So if the conjugate is 8 units, then B must be 4. Asymptotes given by the equation y minus k is equal to plus or minus, oh, why is it erasing all over again? Y minus k is equal to, oh dear, plus or minus a over b. Why is it erasing as I write? Times x minus h. Oh, I wonder if y'all can see it all erasing and are laughing and dreading the fact that this video has already been almost 40 minutes long. Oh, great. My computer's like going a little crazy. Oh dear. All right, let me keep trying this and see if it works. Or not. Alright, I'm about to just tell you the answers verbally. The asymptote ends up being y minus 7 equals plus or minus. When you reduce a over b is 2/4, it'll end up being 1/2 times x. Oh my goodness. This is laughable, y'all. Why does it always do that at the end of the video? Is it just tired? Okay, plus or minus 1/2 times x plus 3. Oh my goodness. Oh dears. This is so sad. Alright, I might just post the answer key to this last one. You get the idea. Y'all have had pretty good practice of this so far. The foci, if you're curious, is -3, 7 plus or minus 2 square roots of 5. I'll post the answer key to this last part on my page as well.